This Diamond High question shows that integration is not necessarily always so difficult. So over here, we are given this question, and I'm fine that Diamond High was very generous with this question because they even give us a clue. They ask us to first differentiate this and hence using this answer to evaluate the second portion. So obviously, when we want to differentiate tangent square, this is just a walk in the park. You bring down the power, you minus 1 to the power, and then you differentiate tangent, you get secant square, right? So in the end, we get 2 tangent x secant square x. And we are asked to use this as a portion to evaluate the answer at the back. So what is the trend that we can see over here? In the given equation that they provided, we can see that very clearly, the whole equation can split into 2 parts. If I draw a line over here, you see that the first part is essentially the differentiated version of the power over here, right? So if let's say the power of E over here is fx, so if tangent square is fx, then f prime x would be the terms that are in front of E, right? But the only difference I can see is that I'm missing a 2 over here because you see my earlier portion when I actually differentiated tangent square, there's a 2 over here. So since there's a missing 2 over here, all I need to do is to just put a 2 over here, but I need to balance it out, right? If I put a 2 inside, I'm completely changing the value. So the trick to actually work around this would be to put a half outside so that when you times 2 inside and you times half outside, the value doesn't change. But now you're able to add in a 2 so that you can create the same equation that you need to actually use the answer from earlier on. And now since I know that this is f prime x and this is fx, then I can straight away integrate this. When I integrate f prime x fx, I essentially just get back my e fx, right? Because when I differentiate e fx, I get f prime x e fx. So when I integrate it, I just get back e fx. And then from here, my two upper limit and lower limit is pi over 4 and 0. So all I need to do is to just sub my pi over 4 and 0 into the equation, right? Tangent pi over 4, you get 1. So tangent square pi over 4, you will also get 1, right? And then tangent square 0 is 0, so you just get 0 over here. And therefore, the final answer to this is just half times e minus 1, and that is essentially the whole answer to this question. And take note that we're supposed to leave our answer in the exact form as well. That's why we don't key the 3SF to this. So I found that this question was very generously set by Diamond High, and it's a question, it's really a staple in the H2 syllabus to be able to do calculus easily. And if you're a J2 or even a J1 student that's struggling with calculus, you need to get more exposure to more question types just like this and get more practice. And I filmed the library of A1 Math Academy just for you and your specific situation. In the library, I have questions from all JCs across Singapore accumulated over the past many years. And I filmed the video answers to every single question in that so that you can watch anytime and revise anytime that you need. And if you want to get access to this library, all you need to do is to WhatsApp this number here. I'll send you a demo link to show you how the bottle actually looks like, as well as an information kit to provide you more information about how this whole library actually works, together with our 24/7 turnaround premium marking service just for you. More information, WhatsApp here, and I'll see you there.